In this video, we will study the distribution of 3 distinct balls into 2 distinct boxes. So let us define the random distribution process. 2 boxes are placed in a main box. So we have box A and box B, and they are placed in the main box. A box is picked at random and a ball is placed in it. The process is repeated 3 times until the table is empty. After that, the balls are returned to the table and another round starts again. So let's see how would that work. So we have 3 balls on this table and they are placed in sequential order, and we pick a box at random. So let's say it's box B, and we place a ball in it. And after that, we return this box B to the main box, and again we pick a box at random, and let's say it's box A. We take the second ball and we place it in box A, and we return this box to the main box. Again we pick a box at random, and let's say it's box A, and we place this ball number 3 in it, and we return this box to the main box. So this is the end of the first round, and now we can start the second round again. So how do we start second round again? We return these balls 1, 2, 3, and we place them here in sequential order, and we start another round again. So let us now create a unique mapping of these balls into a sequence of letters. We will map ball number 1, this ball here, into the box it occupies. So that means ball number 1 is mapped into letter B. So the first letter means the first ball, which is ball number 1, and the letter itself means the box. So now we can read here, we can read this letter as ball 1 is in box B. As for ball number 2, we will map it into the second position here, and we will write in the second position the box this ball number 2 is occupying, and that is box A. So we can read this letter here A as ball number 2 is in box A. As for ball number 3 here, we will map it into the third position. So we will write here the box ball 3 is occupying, and that is A. And now we can read this letter, which is in the third position, as ball 3 is in box A. So when we see this sequence here, BAA, we can immediately know that the first letter is for the first ball, the second letter is for the second ball, and the third letter is for the third ball. And we can immediately know where this ball is. Let's say here, so the second ball for the second letter is in box A, and so on. So let's say we have a sequence BAB, and we want to see that this mapping is unique. So here are the 2 boxes, box A and box B, and now we know that ball number 1 is in box B, and ball number 2 is in box A, and ball number 3 is in box B. So now we have a unique mapping from this sequence into the balls in these boxes. Now let us find the possible outcomes of distributing the 3 balls into the 2 boxes. First, we created a mapping of 2 letters A and B. So the objects are defined over a set, and this set is composed of 2 letters A and B. And the second thing is the sequence is ordered. So if we change the order of the sequence, we change the location of the balls. So that's why order is important. And the third condition is that objects do repeat in the generated sequence. So we may have 2b, we may have 3b, we may have 3a, and since we have ordered sequence with repeated objects, and these objects are defined over a set, not a list, it means we have permutation with replacement. And this is the formula of the permutation with replacement. So we have P, and above it we have R here to indicate replacement. So here we have the formula of permutation with replacement of n different ordered objects taken R at a time. So let's find what is n and what is R. N is the number of objects in the set, and that is 2. And R is the sampling size, and we have 3 letters, so R is 3, and we apply the formula permutation of 2 objects taken 3 at a time with replacement, and that is going to be 2 to the power of 3, and that is 8. So we have 8 possible outcomes of this experiment. So let us see these 8 possible outcomes visually. So we may have all the balls in box A here, so that means the mapping would be 3A, or we may have all the balls in box B, so that means the mapping is 3B. So we may also have ball number 1 and 2 in A, so that means AAB, or we may have ball 1 and 2 in B, so that means BBA. We may also have ball 1 and 3 in box A and ball 2 in box B, so that means the first ball is in A, the second ball is in B, and the third ball is in A. We may also have ball 1 and 3 in box B, so that means the first ball in B, the second ball in A, and the third ball is in B. We may also have ball 2 and 3 in A and ball 1 in B, and we map it, and ball 2 and 3 in B and ball 1 in A, and we map it, and now we have all the possible 8 outcomes of this experiment. But we have to remember a very important fact before we continue, and that is when distinct balls are mapped into non-distinct sequence such as AAA, we have to remember that does not mean that the balls are non-distinct. So we are mapping 3 distinct balls into 3 identical letters, but that doesn't mean that we eliminated the identity of these 3 balls here. This is very important to know. So let us now find the possible outcomes using the tree diagram. In the first draw, we may pick box A or B, and in the second draw, we may pick box A and B, and in the third draw, we may pick again A or B. So we may have now any possible outcome we want. We may pick box A and box B and box B, and we write it down here, A, B, B. And now we have all possible outcomes, and if we want to count them, we can take this first subtree, and the number of elements in it is 2 to the power of 2, and the second tree it's also the same, so we add them together and we get 2 to the power of 3, which is 8 possible outcomes. So let us now isolate all these outcomes alone. So we have all these events. Now let us find the event where we have 2 distinct balls in box A. So that is the event where we have 2 A's here. So here we have 2 A's, and here we have 2 A's, and here we have 2 A's. So these 3 disjoint events, they will give us the event that we have 2 distinct balls in box A. And let us find the event where we have 2 distinct balls in box B. So here we have 2 B's, 2 B's, and 2 B's. And now let us make them look concise and turn them around and place them in this way. But we have to remember what these two A's here represent. So these two A's here represent both 2 and 3, and these two A's here represent both 1 and 3, and these two A's here in the beginning represent both 1 and 2. So if we want to name these events, we have to say, for this event we have 2 distinct balls in box A and 1 distinct ball in box B. And the same thing applies here. So we have 1 distinct ball in box A and 2 distinct balls in box B, because we have 2 B's here. And also for this event here we have 3 A's, which means 3 distinct balls in box A and no ball in box B. And for this event here we have 3 distinct balls in box B and no ball in box A. So these events constitute the sample space. So their union constitute the sample space, and they also create partition in the sample space. And we have to remember that the number of possible outcome is 8. So if we want to know the number of elements in this event, 2 distinct balls in A and 1 distinct ball in B, so we realize that we have identical items in the sequence. So in order to find the number of elements in this event, we can use permutation of 3 objects with 2 and 1 identical items, and that is equal to 3 elements. And the same thing applies here also. We have 2 identical B's and 1 element identical to itself, so the permutation of 3 objects with 1 and 2 identical element is equal to 3 also. So let us find the probability of each disjoint event. So we write down the number of elements in each event, and we divide that over the number of elements in the sample space as we see here. So let us answer the question. Find the probability that box A has 2 balls. So this is the event where box A has 2 balls. So the number of favorable outcome is 3, and to find the probability we divide that over 8 and we get 0.375. Let us answer the question. Find the probability that box A has at least 2 balls. So we may have 2 balls in A, or we may have 3 balls in A. So these 2 events are disjoint. So the probability is the sum of these individual probabilities, and that is 4 favorable outcome over 8, and this is equal to 0.5. So let us find the probability that box A has no balls or box B has no balls. So this is the event where we have no balls in box B, and this is the event where we have no balls in box A. So these 2 events are disjoint, so the probability is the sum of their probabilities, and that is 0.25. Let us answer the question. Find the probability that box B has balls 1 and 3 or balls 2 and 3. So back to the sample space. For the case of box B has the balls 1 and 3 here, we have the corresponding sequence BAB, because the first ball is in B and the third ball is in B. And for the second event, balls in 2 and 3 in box B. So here we have balls 2 and 3 in box B. We have the corresponding sequence ABB, because here we have the second ball in B and the third ball in B. and these two events are these two sequences here. So the probability of this event is 2 over 8. We have 2 favorable outcome over the number of elements in the sample space 8, and that is 0.25. Thank you for watching and have a good day.